All right, good morning. This is Richard Leeson at Searle. And the main thing we're going to talk about today is our new production version that came out on June 30th. At the top of the screen in the upper right-hand corner is the encoding of what this is. So it's version 2.0 2016 June 30th at 16:07. In case you hadn't noticed that, we watch it because we like to know what versions are popping up. And you'll at least need this to be in the newest version if you're able to get to the tool at this time. One of the things we probably have never done is hit this NZP tool. This does take us back to the welcome screen. It's changed slightly. All we've done is updated the name and kind of a little bit of the purpose. There are a couple links here. This does link to our YouTube channel now, so you can get to it from here. It also goes to the National Institute of Building Sciences Whole Building Design Guide. So just to test that, and there we are. Okay, and you can see right here, it goes to the NZP Installation Sustainability and Resiliency Planner with the suite of YouTube. So it jumps right there, so that makes it a little bit easier to get to YouTube channel if from within the tool. All right, what we're going to do is look at our current study where it's at. Remember, our official study is this 1025, and we're going to see what the new version did to it. There's the reason I wanted to talk about this because what we changed is actually going to change the workflow. So it's not just cosmetic. It actually will change the workflow in this new version. There's always a stream of bug fixes and reports, numbers, and things like that. I'm going to highlight a few things, but I mostly want to concentrate on the change in the workflow that will arise from this. So it gives us the ability to have more control and functionality, some things we couldn't do before. So let's get right to that. If we look at a road study, what we have done when we go into the baseline, let it load here, the first thing you'll notice is this thing called the sequence number right here, and that's this number here. It has a pretty strong purpose. It gives you the original view order and maintains it. Now, since this was an existing study, this came up in the alpha order. Basically, if you clicked name, it pretty much came up it's a little bit out of order from this, because you can see where it came in. So it came in an order. But the nice part is now you can change the order to whatever you want, and you can always bring it back to that original order with this sequence numbering order. So if you hit an alpha column, it sorts it by the description, alpha description. The original way it came in, there's a key value behind that, and it's sorting by that key value sitting here behind the scenes. But we can always we can move around, change orders, and always come back to the order that we came in. Now this order is kind of arbitrary, and we'll see what in a new study / updated study the order that we'd like it to come into, and that'll happen in new and updated studies. So one of the things that changed is this sequence number view order. This view order changes how the structure behind and a lot of stuff behind as well. But we're going to concentrate on kind of the functionality here that we see. The other big thing that was added and changed is all the alternatives. Now for every existing facility in here is a default. So if you could have remembered back to the other, is that you'd only see this default for the planned, and at that point what happened was that there was no default building in the baseline. And so you had to be able to come in and specify that initial order or the initial parameters in there. All one, so the default slash baseline had all the parameters, and then all the packages have that reduction in parameters down to the important ones for that efficiency measure. But you didn't have control over all the parameters. So even in the HVAC, we would go to the HVAC. We'd have control over what boilers and chillers, fans, and if we had any reduced ductwork leakage, we would see those. But what we don't see is type of HVAC system, all the other parameters that exist here in the default. And the parameters we're talking about is this zone HVAC. So those don't show up, and so we never had control over those. And I'll give you examples of that once we kind of start into this, where that would come in and affect us. So we could always do that in the planned, but for the existing, we didn't have that. We didn't have that default layer. So now we have that default layer. So now we can go in and change the base case. And so an example of that would be, let's say that this pre-1980, I don't see a mid-century here, but let's say this pre-1980 school building, general instruction building, didn't have air conditioning. So in the baseline, we had heating only, and that can be true on some older installations. The buildings may not be air conditioned, even the barracks. And for the case that kind of stimulated this was West Point. The West Point barracks did not have air conditioning. And then when we wanted to put in the base case, because they were upgrading and doing things, we wanted to show it with air conditioning, but we couldn't turn air conditioning on. So once we had it off, we couldn't turn the air conditioning back on because we didn't have access to those base parameters. So now in our baseline to base case, since this default layer shows up, we have the ability to go in and make all those changes. Next, in essence, you could completely specify the building exactly what you wanted in this case, in using the default case, and you wouldn't necessarily have to look at these. I'm not saying don't look at these and just put it here, and if you did that, you'd of course wanted to put in your install cost. This allows you to evaluate them separately, and then slowly build the integration in. Also allows you to build the costing in per each of the features. But you could do it all right here. And now with this default case, this install cost, if you wanted to override that, so let's say this might have integrated up to $15 a square foot. You could just put that $15 a square foot, select the default case, and that building would be done. So you have the ultimate control using this. Now it doesn't build automatically, and so there's, like I said, pros and cons. And then this default, you'll see that in every alternative. You'll see that there's a default case for every alternative. So what are the implications of this default? Well, one of the things that we used to be able to do, we used to be able to go to the baseline, make a change in that baseline facility, and then would sweep through all the alternatives because the default was the baseline for all the alternatives, since that default case didn't exist. And now with this default in each of these alternatives, if you want to make a change in the baseline and you want that same change to be made in all these alternatives, then you would have to go through each of the alternatives and change its default to that value as well. So it can add work if you go back and you have to make changes, because then you'd have to sweep that through. You'd have to sweep that through everything to make sure it pulled up in each of those alternatives. So that's the downside. So if you're trying to go back and sweep something through and you want to sweep it through your alternatives, that's the downside to it. But there's an upside. Like I said, we get control, and we also get this thing called this sequencing. So what I'm going to do is I'm going to leave this study for right now, and I'm going to go to a copy of this study, And we're going to go ahead and play with this and show a few things with this study. So just so happens that we have a copy of this study that I made, and it's a pretty good sized study now. So this took 10-15 minutes to copy, because remember, it copies everything in the facilities, everything in the installation, it copies everything into the decision analysis. So to make a complete copy of this, it takes a little bit of time. So as these grow, understand that happens. Okay, and if you'll see in our copy, it's all here, and that's the good news. But let's go back here. We're gonna, like I said, I was going to say mangle it, but we're going to utilize this study here and look at these things a little bit. So what you see here is this. This is also these are the versions of the tools that do the calculations on the job server in the background. So in this one, we have an energy param version of 0.39, and NZI version of 0.1, and water and waste and stormwater. So we see these versions here, and that's okay, because we're not going to really update this param version because it's not new, but we're going to upgrade to it. And what it does is it rewrites all that information back into the study and then kind of resets everything. So we'll just quickly go back and take a look at where it currently is, and then we'll see what happens when we upgrade those parameters. And then the decision you'd have to make on what you would, on kind of the path that if you want to take an old study and kind of and get some of the, and get anything, if you want to upgrade these things, what you would have to do this, and then what the implications are for all these, for having that default study in there. And probably what I would do. Now, it gets a little bit more complicated when you have installation stuff and all the changes there, but we keep the original study, and many times I have another study pulled up with the original and with this one, and you just compare back and forth. Actually, I have two different Internet Explorers open in two different screens, and you can compare back and forth, and you can move the values pretty easily once you get to that point. But let me tell you how I would do the workflow on this. And so, like I said, this is a copy. It's brand new. And so one of the first things I would do, I'd go to the alternatives. And like I said, we have the alternatives. We've made changes in package selections and maybe a few EEMs and a fair amount of work in selecting different equipment and different parameters in the installations. But like I said, a lot of that's knowing what things we did change, and we can find those pretty easily from the other copy. So the first thing I would do is go back and strip this back down to basically delete the alternatives back down to that baseline and base case. And the key is to do a really good job on the baseline, and then a really good job on the base case before you even consider moving forward. Because if you remember, if you click to create a new alternative here, it copies it fresh, and you have to do all the work. But if you copy the alternative, all the work that you did in the alternative, in this case the base case, gets carried forward. So in other words, if you made changes to that default case, if you made changes to costs, everything, so all that's carried forward. So you want to do a really good job on that baseline and base case before you copy and start generating those alternatives. The hard work is done in setting up those baselines and base cases, and then going through, even in the base case, remember we talked about that, to set up the costs for the ECMs in that base case. So when we copy it forward, you may not be using it in the base case, but when you copy it forward, it's there. So all you have to do is make package selections and set a few parameters in the efficiency measures to get that. Okay, so we're going to once again keep stripping this down to just the baseline and base case, and then we'll show what it looks like. Then we'll go and update the params, and we'll show what happens to those parameters. And remember, this is a copy. This is not the official version. that's the nice part about being able to copy the study and then going off and doing what you want. Because even if you mess this up, I just delete it and start over if it gets that bad. All right, so we're down to 2 alternatives. And I mean, that shows up everywhere. That shows up in the installation. So it simplifies it. The processes move a lot faster when that's happened. And if you notice, you'll see the 2 different clusters showing up here: the centralized buildings and the decentralized buildings. All that shows up, and in here when we got the new buildings in it. So we had some new buildings built here, and so yeah, this all shows up very quickly. Now when you have two cases. All right, so this is 1076. So we're going to go back to the study list. We're going to go back to 1076, and in here we have this upgrade button, and we're going to come here and we're going to upgrade params. We're going to let it do its thing, and knowing now it only has to upgrade the baseline and the base case versus 5 or 6 alternatives that we had. I think we deleted 4. So the update was pretty much quicker as well. But more importantly, when we get into everything here should be the same. We should have the same 2 that we came down to. All this should be the same. So what's going to change, if you notice, this has all been reset. So what's going to change is when we come into the baseline. Now we should see something quite a bit different. Besides the red dots, what I want you to think back a minute ago was when you saw that sequence number, what was that first parameter sitting there? Anybody remember that? So it was air changes was it. So remember, it was in alpha order. Now if you notice, it's groupings on how it kind of originally came. It was that we've actually generated the parameters. So let's look at this a little bit. Let's look at this a little bit more. Yep, there's really nothing there to show. So it all shows in a grid, which is good. We always have this capability when it's there. So the slab parameters is the first thing that shows up, but the nice part is they're all grouped together, even though the names may have spread them out through when it was done alphanumeric sorting on that. But I can go back to that order. So remember that air leakage rate, that was the first one there, if you recall. That was there because that was that key behind it was the first key name. But if you notice, the sequence numbers is right here. I can put it right back into this order, and like I said, this is important for us because it kind of groups the parameters and groups the effects on the simulation. So this set here is all the slab insulation. This set here is all the roof information. Now, so like I said, some of this may have been in little chunks, but this is now you'll actually see them all together. Same thing for the walls and windows. And then now you get down to the air leakage rate, but there's another thing. Right here, all the air parameters are together now. So you see the air leakage rate, the infiltration fraction, the upstream leakage and downstream leakage all show up together. So kind of all the air parameters show up together. And then we see we've got the lighting schedules show up. There are controls, return air fraction, and all this lighting. I'm sorry, the lighting schedules are here, but the lighting densities are right here. So this is all showing up together as well, which before may have been spread out over the inputs. Same thing with the equipment. That's all together now. The occupant densities and their schedules are all together. Domestic hot water. So now the equipment and all the settings are all together. Now we're moving into the heating coils, the heating set points, the types of coils, the setbacks. All this is together along with all the systems. But what was more difficult before is when we changed. Let's see this VAV reheat right here. If we look at this, and then we look at the HVAC air system type, is a VAV. Where a lot of us get into trouble, including myself, this is going to help me a lot, is something like this. We want to change this. Now, if I just change this alone, this will crash, because if you notice, I changed to VAV multi-zone, but my multi-zone terminal type is now a constant air volume. So here I would have to change my VAV multi-zone, but then I'd also have to change my multi-zone terminal type. And you have to know a little bit about HVAC, and that's okay, because that's why we have a couple people on the energy side here who are looking at these parameters, and they're going, oh, I see. So there's a few parameters in the system section here that are all grouped together now, so you have some idea of what things are related to them by their grouping. And so I'm just going to reset this to default, because I'm not trying to make this work, just show you the effects of this and how it does. Okay, so there we go. There's the VAV, reset that to default. Okay, so if you look at the radiant control types and see, here's all the other radiant parameters. You're looking at the fan efficiencies, supply fan pressures, and their efficiencies, the return fan pressures. Here's all your controls for the supply air temperature. The key here is that they're now grouped, and you need to, once you find your group, you look through that group of parameters. If you're diving in this deep, and if you're not, then that's okay. But you have a better chance of seeing these, of getting to these groups, because they're now grouped by this sequence number and not just by their name. Okay, so that, from my perspective, is a huge benefit. So that's one piece of this, and the other piece, as I said before, is that this is the baseline, and so we know all these baselines have that same thing. And if you want to get it close to where it was before, if you knew where it is, you can just click on any of these. You can click on any of these and sort it. But the nice part is you can always get back to that original ordering of the parameters by clicking on that sequence number. And that is going to be the default order that it comes out in, is this sequence number. And so when it comes back, this is going to be kind of like the default viewing that you'll see. And like I said, from my perspective, that's a big benefit just by itself. Maybe not enough to go upgrade the parameters in an old study, depending on how much other work I did. But if nothing else, maybe I might look at a new one and look at that as a reference. Okay, so workflow. We have to make sure that we get a good baseline set up, and we want to set up these baselines. And why is that? Well, let's make a couple changes here and see what happens here. And if you recall, one of the big changes was in the HVAC section, and sometimes it's easier to say zone HVAC, and it's sitting right here at the bottom, so that's why you can just flip it around as necessary. These are fan coils, and if you remember, the fan coils have a completely different energy consumption from a VAV reheat, which came in here as the default. The vintages play less importance in the HVAC systems because they're just all over the board, right? It does a lot differently in the when it comes to the envelope parameters. So the envelope parameters, the vintage, can affect it more strongly. But you need to go back and look at the HVAC parameters and systems. So in this case, we got a pre-1980. We got the fan coil here. Let's just quickly look at that for some of these from these pre's here, and probably that might be a fan coil. Now I can change from a VAV to a fan coil without having to change much else. It won't crash like some of those. If you change to the VAV multi-zones, if you don't change the terminal units to match, fan coil is a different set system there. Okay, so I'm taking some of these pre-1980s and moving them to things that would be more in line with maybe that era. and trying to do something that would, that won't bomb it right away. All right, existing. Here's another pre. This is our health clinic. Yeah, okay. I'm going to leave it. I can't change it easily. I'm not going to get. It's just a quick demonstration here. All right, now that's a good default here for this one. Okay, so we have the rooftop unit, which for this temp is good. Okay, so we've changed a few of these. So let's go ahead and resave those, and let's look at what happens to our base case when we go forward. I think now our base case came in, and it came in updated. But when it was created already from it wasn't just created after I made those changes to the baseline. Okay, so if you recall that we made those changes here in this default, and if I go, let's just change that order and go straight to the bottom. That default case was fan coil air. Now it isn't just because it wasn't just because I don't think it was because of that. I think it was because that was there already when I deleted it. So I want to find another one that we changed to kind of verify that. I think we looked at that gib. Oh, no, I'm seeing changes in there. RTU. Infiltration package. Fan coil air. Well, that's interesting. I'll have to play with that a little bit more myself. That default was carrying those forward here, and we didn't create that default. And I don't really know if this is remnants from the previous when I've changed those. So I'm making some of the same changes, or if it carried that through to this default. So I'm going to assume that that's a remnant at this point, because the point I'm trying to make is so let's say we made a bunch of changes to baseline, and we have this base case sitting here, and we hadn't really worked on this. So we delete this, and then when we click here to create the new alternative, and we create that study, then when we go to our facility loads, and we go to our base case, when it's created, it writes all those baseline parameters over. So if you're not quite sure if those values are carried forward into this default case, when you create the base case, it writes all the baseline parameters in here. So we should see those parameters showing up here for sure, and exactly the ones that we changed. So like I said, if you're not quite sure, the way to make sure is to write that base case from the baseline. The point of that is when you do all your work in the baseline, you want to make sure it's done, because if you don't, you will have to come back into, like I said, the default in each of these alternatives in this base case. And then you'll have to make those changes there. Then you'll have to make them in whatever other alternatives. So depending on the workflow, we want to definitely complete that baseline all the way. So I know people had typically created the baseline, played with it some, and then they created the base, better, best, all three of those. And then they started working on the base case, and then they started working on the others, and that work isn't getting carried forward. And some of the work was okay, but now with that default case in there, if you want to make sure that that baseline gets carried through to all those defaults before you start making changes, then you need to make sure that you're completely done with your baseline. Then work on your base case, and then you want to work on your base case, and you want to go into your base case and go into all these efficiency packages and make sure that the install cost is what you want it to be before you create your other alternatives. If you make all the changes, even if you don't, like I said, even if you don't use these efficiency packages are not selected in your base case, you can always, but if they're not, it'll always carry the install cost to each of the future alternatives that you create. And so it's what you want to do is, like I said, is you really want to spend the time in a baseline. You want to really spend the time in a base case, get all those values there. So as you move forward, we're copying those. And not only does it take away some of the work, it gives you more consistency, because when we copy those alternatives in the database, we can, it's easier to copy it there and keep track of it than it is for us to do that. Okay, so I'm going to go ahead and save that, and then try to give you an example of why this default case can be very important to you once it saves. There we go. So let's just use this first one here. So let's say at this brigade headquarters, what really happened was, if you recall, and like I said, it comes out in this initial sequence number, but if you recall, we changed it back to a fan coil. But let's say in the deep energy retrofit of this, other things have changed besides these efficiency packages. So one of the things could be the facade. The facade may have gone from stucco to brick or something else. So one of the things that you could not change in here in the efficiency things is what may have happened to the envelope, the exterior. So if you hear, you'll see that the insulation types are here, but you won't find any of the finishes in here as well. So there may be something like that that can change, and I'm just trying to find something to work as an example. Okay, and then for whatever reason, in your base case, they may have figured on not upgrading this, or they might have upgraded this. We don't know. Okay, so in the base case is what they would have done anyway. But let's say they were going to now change this to they were going to upgrade the system, and they were going to go to a VAV, so a more efficient system. This you could not do. You could not make these changes previously. So now I can make this into the VAV as my base case, and then go forward and add efficient equipment in my alternatives. Or it may have not gone quite as efficient, and I may have wanted to change it to VAV in, let's say, the better case or the best case. They may not have specified it that they were going to do it in the base case, and you came back and showed them that they did. They probably are going to have to do this in the base case, because you got to remember the base case is where they were going to spend that money anyway, and so you want to make sure, because it's hard to justify unless it's an incremental change from what they were going to do in their deep energy retrofit. It's harder to justify swapping out a system, and but you might be able to. But the point is, if you do make that change and it's an upgrade, something beyond what they were going to do, you would have to put the incremental installation cost for that. If it's in the base case and it's something that they were going to do anyway, they'd already budgeted for the VAV, then this would stay as the base case value. So there's no incremental cost to move to that energy efficient measure. But in this case, let's say they were going to retain that, and we wanted to move to the VAV. You might have to add in a value for that upgrade. Okay, so there's like I said, there's a workflow issue. And then in the better and best, you could be evaluating these parameters to go on top of that, and there's quite a bit of difference in there. So we're going to once again, let's go ahead and save that with that little change, and let's see if we can get this to get running. And then while that's running, we can look at some of the other things that have changed and could be and can be helpful. All right, so we have saved each of those alternatives, and we got quite a few runs to do, and we'll let that get going, and we're going to do what we do a lot of times, and that's open up another session and poke around in that while that's running. Now, one of the things that you should notice when you load this the first time, and you might know that there's a new version out, is you'll see that spin up. Okay, let's go back to our official study here. We'll look at a few other changes that have happened here. So in facility loads, and if you recall that Matt had talked about this demand by end use file here, and there's values and costing and things. So they put together this helper spreadsheet and then loaded it with these values. So load it with these, the demands and the peak demands, and this is what sizes your equipment. And so if you look here, you'll see that the cooling equipment is 3,828 kilowatts. This is actually for 4 facilities with 360,000 square feet of area. And then our peak demand for gas is in kilowatts. And if you remember that insulation section, it likes kilowatts as the input. Obviously, we can change it and look at different values here when we're looking at this, but ultimately when we go to the spreadsheet, and if we look at our better case, just look at that same case, we can see that with the improvements that we have made in the better case, we've dropped the demand down to 1,800 kilowatts and 3,300 kilowatts of gas. So those are important for sizing and costing, and then of course doing away with some of those peaks that we want to get rid of when we're looking at the equipment. But now he talked about having that helper spreadsheet. So that helper spreadsheet is now available, and it has, if you remember from previous classes, that in that helper spreadsheet there's the summary of the areas and these are I'm pretty sure, I think this label is wrong, so I'm pretty sure that's kilowatts and not therms per hour. Now you can go back and look at the value. I did that earlier. You can go back and look at the value here and the value for kilowatts, and you look at the changes that are made. So anyway, we should see the in the better case, see, remember it dropped down here. This is split out into and this is by end use. So you got your cooling peaks, and so this is split up into different things. So this is just the electric cooling peak. Remember, it's 3,800 total, and you need that for sizing. So that's why you had to have by end use. This is just the electric cooling piece of that. So it's a little different, as it's lower, but it's still the majority of that electric cooling. But this is what you're actually going to size it on. And remember, out here it had the costing tables that were built in to give you a rough idea of those costs and the maintenance costs. And then we went here to this, and then we had to do this click thing, which they haven't resolved that, and that still is in the works, and it will be resolved, and a new helper spreadsheet will get loaded in there when that becomes available. So all this is now here and available in the production version. So this, definitely gets you started and going. And then just as a review on this, go back and review the other video on when Matt used this. If you get that far into the installation section, we probably have some time, and then Matt we'll get that upgraded helper sheet put in there. But it's now the template and everything is available, loaded with these demands. So it's a big step forward, and we'll get the rest of that cleaned up and fixed and inputted. So that's one of the things that came out. The maps have finally been fixed, and we saw earlier that they popped right up when we went and looked at those clusters. The graphics loaded for all those, so you could get it worked here, and it also worked in this map view. There we go. There's the map view, and it has the same features to visually group or not visually group. And this is really nice because it shows you both clusters overlaid on one another, and this is a very quick depiction and gives you a really good idea what's going on in your system. So the outside of this is the decentralized, and of course that's the centralized piece. Okay, the other thing that changed, and we talked about that in the when we did the MCDA, is what this is actually based on. Is it based on the baseline or the base case? When we look over here, we looked at the energy savings, and when you look at 0 and minus 34, and then you look at these percentages, it gets a little hard because you're not really comparing it against the baseline. You really are the base case, and so now the baseline base case has been input in here, and it's correct. And this changes what the denominator is for this calculation, and all we did is move that to the base case. And so we can see basic that's terrible. Basically, for the base case is that it zeroes this one, and we see that we actually used 25.8% more energy going to the base case than we did from the baseline. But if we recall, we come over here and we can see that we've also gone from 3 million square feet to 4.5 million square feet. So we kind of get that as we build new facilities and we put those in here, that we're kind of we think there's going to be a change. And the nice part is now we can come over here and we can see where that. So we know that when we go to the better case, we've actually almost back to our baseline, but with the additional over 1 million square feet of buildings, we're almost back to the same amount of energy. And in here we can see that we've actually improved over the even over the baseline here as we get over this 25. So our base case, though, is, as you recall when we talked about this in depth in the MCDA models, that is what we're comparing against. That's our future case. That's with all of our buildings. That's with everything there, so that we know that's what we would build. We think it's great when we get to the better case and we can get back to where we were at the baseline. Our bills are no bigger than what they were when we didn't have all those buildings, because we built them better. We built the buildings better, and so this is great when we get to this point. And of course here this is even better as we improve beyond that. Okay, so you can easily change that now. Also, you can see there's some other cleanup that's happened here, and also in the facility loads. When we look at the results section here, this screen is a lot cleaner. It now just has the reports that are available, and a lot of the filtering and stuff that wasn't really used or has been taken off, so we don't have to look at that clutter visually. So all that's going on. Let's go back and see what's happening in the other. So 195 are done, 20 are in the queue. Let's see where we're at. 10 errors. Okay, so this would take a little bit. We could go look at this, and it's probably going to be in the that's going to be when I change the systems. And in many cases it might only be like one building. So this gib right here, in this case there's one error, and in this base case it gets it with the alternative. So I know that there's definitely a problem in our baseline for the gib, and as an exercise we can go take a quick peek at that. Let's see what we did to that gib, and that was what gib existing pre-1980. What did we change? Okay, yeah, so we changed to the rooftop unit. So I lied. We would have to, there's probably another value to change here. But for expediency, just to show you that it's just that system change, and then we'd have to go and look at this a little bit more, is just to change that real quick and see what happens. All right, so if I take that forward and I look at that baseline and rerun that baseline, we notice it popped right to being done. But notice that these guys are staying the same, and if I tried to run them, they're still going to fail, these 9 simulations. And that's because of what I said before about having that default case. So before, if I would have changed that baseline, that would have filtered through to all those alternatives. But now I have to make that same change in the default case for that gib, and there it is sitting right there. And if I don't change that, it's still going to propagate that same error. So this is like I said, where I said you have to really work on that baseline, and then make sure that you get all your changes working. And you have to really make sure before you copy it, so then you copy that solid baseline as your alternative, then start working on the base case. So the warning word here is to do the work up front and get it to where you're really comfortable and it's solid, and then you can move forward, knowing that if anything, you can always go back and change it, yes, but you always have to kind of sweep those changes forward. And so now if I move forward into that simulation piece and I go back to that, and I can always hit the button and do it all, but we always have the ability to either to go into do it absolutely in an individual one. I can just simulate that, or I can do this whole group. In this case, I'm just going to do the whole group, and boom. And the reason it popped to green right away was that feature that we built in there. If it finds a run that you've done in the past, or anybody's done in the past for this inside the database that matches that exactly, it'll pull those results up. And obviously this has been done in the past because we've run this with those cases before, so it just pulled those results up. So now it's done. So at some point, if I want to really make that a rooftop unit, I will go back and look at that. Like I said, today was just mainly to show you workflow and how the changes that we've made to this production version have changed. It's been just a little bit more than just some bug fixes, and so we really wanted to talk about what was in that before you went forward and looked at that thing and then found out, hey, this is a lot different. So there's a reasons why it's different. This is kind of the impact. Gives you a lot more control, a lot more situations, and you just have to work a little bit more up front and carry your changes and copy your changes forward so that you don't you can minimize what you have to go through and change and save as you go forward. So after that, everything is pretty much the same once you get past that. And then if we look at that brigade headquarters that we had, let's put that up there. We see it's right here at the top, and let's sort this one and put it at the top as well. remember I changed, the only thing that changed was going from fan coils to VAV, if we made that change. So let's see what we have here. So here we've got site electricity intensity of 70, gas, and this is all in kBTUs for recheck on our units, for a total of 102.89. And just changing to a VAV from fan coil without improving the building or doing anything else, we're going to get, we go from 102 down to 79, almost 103. So we see about 24 kBTUs per square foot by the system type. And so we see a 17% reduction in electricity, 35% reduction in gas just by going from a fan coil unit to a VAV. And in big picture, VAVs are still one of the, it's at this point in time, the technology is solid. It's one of the more energy efficient systems you can really put out there at this time. There are some tweaks that we're trying to do with variable refrigerant volumes and some of the others. I'm going to say exotic today, and if I was back in at 1980s, I would have called the VAV exotic, right? So it's just kind of, that term kind of moves with time and how long that technology's been in place. And it's being used. Can we save more energy with VRF? Some cases, yes, we have to, and we're still evaluating kind of the amount of refrigerant that's in the system and getting passed around, the complexity of the system, the maintenance of the system. I'm not here to proclaim one or the other. I'm just pointing these things out at this time. But the system type and choice, when we from that baseline to the base case, it used to be very, very, very important to get it right in the baseline, because you couldn't make a change once you went forward. Now we can make that change and we can show this. So that same building may have been an existing building, and that system may have been upgraded, and now we can get it. We can get that base case and or a future alternative with that choice in it, which we couldn't do before. And or if we, going back to that quick discussion on that West Point barracks, if we had the cooling shut off, we couldn't turn the cooling back on in the base case and alternatives. And so we had to go in there and to kind of get over that. We actually kind of drew a shape in, called one a demolished building and one a planned building, and then try to made sure that all the parameters were the same between that demolished to that planned, and then we carried forward. So it wasn't, we were able to kind of have it was hard work around when we wanted to do this. And then at some point, we just kind of, it just gets to be too hard to do. And so ultimately, the default case was put into all these, and that's kind of the new norm now. So we're just going to have to get used to that workflow as we go forward. And for the ones who've been waiting on it, they're thankful it's there, and they're going to move forward with that.